first question here says, if the mass of a baseball is 149 grams, what is the kinetic energy of a fastball clocked at 100 miles per hour? So we should know from reading already that kinetic energy is equal to 1/2 the mass times the velocity squared. We've got to make sure these things are in the right units. We know that the mass of the baseball is equal to 149 grams, but we need to change that to kilograms because that's what's needed in order to do our calculations here. So we change that to 0.149 kilograms. Okay, so there's the first step taken care of, no problem there. But we've also got to change our 100 miles per hour. So our velocity is equal to 100 miles per hour. We've got to change that to meters per second. So we should know at this point that 100 miles is equal to 100 miles. We're going to change that. We're going to put miles down here. We're going to put kilometers up here. And so we know it's 1.61 kilometers in every 1 mile. So that gets rid of our miles. We got to change that from kilometers, though, to kilometers to meters. So that'd be 1 kilometer here on the bottom, and it's 1,000 meters on the top part. And so that would cancel out those units. And then we've got to change our hours to seconds. And so we would know that 1 hour is equal to 3,600 seconds. So when we do the math on that, we'll wind up with a velocity which is 44.7 meters per second. So we take our equation back in here, we put it in the right units here. Kinetic energy is equal to 1/2 of the mass, which is 0.149 kilograms, times the velocity squared, and the velocity in this case is 44.7 meters per second, and then we will square that value. We do the math on that, and the kinetic energy winds up turning out to be 1.49 times 10 squared times 10 squared. All you're doing is 1/2 of these numbers multiplied, and you square 44.7. 1.49 times 10 squared, and that's going to be kilograms meters squared per second squared. And those units, kilograms meters squared per second squared, is the same thing as a joule. So that would be 1.49 times 10 to the second power joules, or you could say 149 joules of energy. So that's what we would be looking at for the first problem. Now the second problem that we posed here is a batter hits a pop fly baseball, same baseball, 149 grams, reach altitude of 250 feet. If we assume that the ball was 3 feet above home plate when it's hit by the batter, what is the increase in its potential energy? All right, now potential energy is actually going to be, oh man, I don't have my equation in front of me, the mass times the acceleration of gravity times the height. The mass times acceleration of gravity times the height. So the first thing we need to do here is potential energy equal to mass times acceleration of gravity times the height of the object. We need to find the mass, which is given as 149 grams, but that would actually be, once again, 0.149 kilograms. And then gravity, the acceleration of gravity is 9.81 meters per second squared. And then the height of this is given as, what did it say the height of it was? Why am I not looking at the right page here? The height is 250 feet, but we assume it started out at 3 feet above home plate. So we'd have to have our height is 250 feet minus 3 feet, which would be 247 feet. Okay, so that's the height. That's the increase in potential energy because it changed in a height of 247 feet. However, we can't use feet. What do we have to use? We have to use meters. So 247 feet would be 0.3048 meters for every 1 foot. And the math on that would give us a height. Hold on, I've got to calculate that one because I didn't pre-calculate that one. Of 0.3048 times 247 of 11.856 meters, or 11.86 meters. All right. So it's mass times the acceleration of gravity times the height of the object. So we'll work that out. Potential energy will be equal to the mass, which is 0.149 kilograms, times acceleration of gravity, which is 9.81 meters per second squared, times the actual height, which would be 11.86 meters. We'll wind up doing the math on that. We'll get 1.10 times 10. I put times like that. That's not how I usually write that. Times 10 to the second power, and that's kilograms times meters squared over seconds squared. And remember that that is our units for the joule. So it's really 1.10 times 10 squared. Put the times in there. Joules, which is 110 joules. That's the increase in energy, potential energy, for the ball whenever it's at its highest point.